Good evening, students. Today we are going to learn about the conversion of one shape of a solid into the another shape. So while changing the shape of a solid, what remains constant and what is going to be changed? Those things we have to learn. A student, keep in mind, it may be given that a cylinder or a metallic cylinder is there, and this cylinder is to be converted into an sphere. Then what will be the radius of that sphere? Means it may be given that a cylinder of radius r and height h is given to you. This is converted into an sphere. Then what will be the radius of this sphere? Will it remain same as the radius of cylinder? What will be the surface area of this sphere, or even the volume of this sphere? Or volume of this sphere? What is that? So what is going to change and what remains unchanged? A student, we have learned that for a matter, if the matter is solid, then a space occupied by that matter always remains unchanged. Get it? So for solid matter, it is the volume which remains unchanged. Remaining other thing like their radius, their shape, their surface area, all these things will change. Get it? Like if you have a bigger metallic sheet, if you melt that metallic sheet into the small or into the shape of a sphere, then you will observe that the surface area is getting reduced. The sphere have a new radius than the length and width of the metallic sheet. So the important thing in this conversion is that, so write that point. So while one shape or this solid shape, a student, keep in mind it should not be hollow. If it is the hollow, still you shall take the volume only, means volume of the material only. While converting one solid shape into another, the volume remains unchanged. Volume remains unchanged. This is the only concept. How to apply this concept? So we have to keep in mind it is the solid shape. So solid shape means the material used. It is only the material which is present in this shape. Say if you are taking the hollow cylinder, then you shall take the only thickness of that hollow cylinder, only that much material, their volume you have to take. So it is the material you have to take. Its shape is going to change from one into the another. So this can be written in the form of equation like the volume occupied by first shape will be equal to volume occupied by new shape. Or you may write this as the volume of material in new shape, means the another, the new one, it is the new. And the solid shape means one, it is given, or this is our old shape. So volume of material in new shape need to be equated with the volume of material in older shape. So this thing we need to keep in mind. The volume of the material remains the same. So that have to be equated. Example, say a cylinder is converted into an sphere. So whatever the volume of cylinder, that you need to take. So it simply means volume of cylinder or volume of material in the cylinder, if it is the hollow cylinder, should be equated with the volume of a sphere. Only this is the concept. Then how to apply this? For that, let me take one very small example rather than making the question. Let us consider. Consider a cylinder is there. This cylinder have the radius of 14 centimeter and height of 21 centimeter. This is a solid cylinder. This is melted to form an sphere. Then what is the surface area of this new sphere? That we want to know. This is converted into a sphere. So whatever this cylinder is there, for this cylinder we are having the height and radius. For new sphere, what is your surface area? What is that? If it is asked what is the volume of new sphere, then answer is very easy. It is same as the volume of the cylinder. Here we are considering the cylinder and sphere both as the solid one. Do not think that these are the hollow. So you may feel it. These are solid one. Be careful. These are the solid cylinder and solid sphere we are taking. We are interested to calculate the surface area of the sphere. A student, will the surface area of a sphere same as the surface area of cylinder or not? Will it be equal to lateral surface area or total surface area or what? So MCQs are even framed just by taking this statement or from this statement itself. The surface area of a sphere will be same as surface area of the cylinder. Volume of a sphere same as volume of cylinder. Radius of a sphere same as radius of cylinder. This way MCQs are framed and they are very easy. Only it is the volume that remains the same. But volume remains the same doesn't mean radius remains same, or that doesn't mean the surface area remains same. Keeping the volume same, the radius, surface area, other quantity may vary. So for this new shape, we shall take the new radius. Let us denote it by R. So let the new radius be R. Then for this condition, means while it is transforming or recasting the volume of cylinder, so write down this solution. So volume of cylinder have to be equated. It is already written here. Volume of cylinder have to be equated with the volume of the sphere. It means for the volume of cylinder, write down the formula. It is our pi r square h. So this 14 is representing the radius of cylinder, denoted by a small r, and the height 21, let us denote it by h. So volume of cylinder, here we have taken volume of cylinder as pi r square h, and the volume of a sphere you need to take, it is given by 4 by 3 pi r cube. Keep in mind, do not use the same r as we are using for the cylinder, because it will give a new radius. So denote it by new alphabet. Let us denote it by capital R. You may denote it by RS or R2, like that one. Though, so we have to equate these two volume. So volume of cylinder we are going to equate with the volume of a sphere. Therefore, pi r square h should be equated with 4 by 3 pi r cube. Is it okay? This thing we have to take care. Now, in such condition, you are observing that the pi is always getting cancelled. Now go for substituting the given data. R, the radius is given as 14. So there is square. Or many a time, even this can be rearranged in the term of a small r and h itself. Means r square h, these three will multiply here, and 4 will come in denominator of this. It will remain as r cube. Or even the r cube radius of a sphere, bringing this on the right hand side, or remove this cube as the cube root of 3 by 4 r square h. It is the cube root that we have to take care. So this is the radius of a sphere. So this thing we have to keep in mind. Go for substitution of the given data. It is the cube root. 3 is from the formula. Radius of this cylinder, it is about 14. So 14 is square. We may write this as 14 into 14. And h is our 21. We may take this as 21. Divided by 4 is in denominator. It is like this one. So everything is inside the cube root. So be careful. Go for simplifying this. What can be cancelled? This becomes 7. This also becomes 7. So it becomes cube root of 3 into 7 into 7. And this 21 can also be written as 3 into 7. Only this much. Nothing in denominator. So we are observing only this 3 can be taken out. Sorry, only this 7 can be taken out, and the 3, 2 of the 3 will remain inside this root. So it is like 3 into 3. So it is 7 cube root of our 9. This is the radius of a sphere we have calculated. But what is required is the surface area. Therefore, the surface area of a sphere is obtained by, how much is the surface area? It is the complete sphere. It is 4 pi capital R square. So go for substituting this. So it becomes like 4. If you wish, you can substitute the value of pi as 22 by 7 or make it as it is. Then R square. 7 cube root of 9 square. The students are waiting for 9 o'clock. Yes, Neeraj, you are also habitual of starting our class at 9 o'clock, though we have already finished for nearly 20-minute class. Okay, so just you have to simplify this, you can get it. So 4 pi you may substitute 22 by 7. It's very easy. Then it is the 7 square. You can write this as 7 into 7. Then it is the cube root of this 9 square. You may keep this cube root here. It is 9 into 9. You can cancel one of the 7. So it is like our 4 into 22 into one of the 7. And inside this, it is like 3 into 3 into 3 into 3. 4 of the 3, 9 into 9. So one of the 3 can be taken out. What is left inside the cube root is one of the 3, and order of these 3 will remain this much. So this, you just simplify this much centimeter will be your answer. It's so simple. So this is the concept of transformation. So what is important to be kept in mind is that during the transformation or during conversion of shapes, the volume remains constant or remains unchanged. The volume of the two shapes need to be equated. It is the only concept for this topic. Okay, so it is this one. So by this way, let us go for some of the questions from our textbook to understand it even better. There I have taken only one of the cylinder converted into the sphere. It may be possible that more than one cylinder converted into the single sphere, or the sphere converted into the cone, or n number of a small sphere or the balls get converted into a single cone. Again, the volume have to be kept constant, multiplied by the number. So let us take the question number 1 of exercise 13.3. In question number 1, a metallic sphere of radius 4.2 centimeter is melted and recasted into the shape of cylinder of radius 6 centimeter. Find the height. Same as earlier one. A student, you first draw the figure of the two shapes. Write the formula relating their volume for getting the unknown quantity. Then whatever required, so for the surface area, you apply it at the end. So a metallic sphere, it is talking for this single sphere only. Draw the radius of a sphere. You may write this as RS as 4.2 centimeter. This is converted into a cylinder. So draw another cylinder. Over this cylinder, write what are the given variable. Cylinder of radius. For this, let me denote the RC as the radius of cylinder as 6 centimeter. You need to find the height of this cylinder. What is the height? We can apply the transformation, equate the volume to calculate the height. It may be asked, what is the surface area of this cylinder? It may be asked. So add it here. Also calculate the surface area. The surface area. Surface area default meaning is TSA of cylinder. Okay. So this is the additional thing that we will calculate. So very first, even for calculating the surface area of any cylinder, we need both radius as well as their height. So height calculation, even not asked directly, if the surface area is asked, still you need to calculate the height. So right, for this is the case of transformation or conversion. So first write down the volume of the sphere. Volume of a sphere can be calculated by 4 by 3 pi r of a sphere cube. Volume of this cylinder, it is pi r of cylinder square into height of cylinder hc. It is this one. Volume formula just we have written. Then you have to write since on recasting or conversion, the volume remains unchanged. It is the volume of the material basically, and it is considered as solid unless or until it is stated as hollow. The volume remains unchanged. Therefore, from this statement we can make the equation, that is volume of the new shaped cylinder should be equated to volume of sphere. Though this hc we want to calculate, that will automatically come from this single equation. Substitute the formula for volume of cylinder. It is our pi rc square into hc should be equated to 4 by 3 pi r s cube. Now go for cancelling the pi. What we are getting? hc can be calculated by 4 rs their cube divided by 3 is there, and rc will also come in denominator but their square. This I have just rearranged the known quantities so that unknown can be calculated. Now go for substitution. So do not calculate the volume of a sphere initially by substituting pi, then volume of cylinder, then equating. No, that will lead to wastage of time because the pi is going to cancel. So first equate the formula, rearrange it, then substitute it in the final one. Put that habit. So it is 4 into rs. The radius of cylinder is given to us. Sorry, the radius of a sphere is given to us. It is our 4.2 cube. You may keep it this as the cube or multiply it by 3. And the radius of cylinder is also given as this 6. This is our square. So this simplification is very important, student. It simply means 4.2 into 4.2 into 4.2. So if you have doubt, please do it completely by opening each of this exponent. So 6 7 ja means it is like our 0.7. Then 6 7 ja, it is like our 0.7. Then this 3, this is our 1.4. So ultimately, what is hc? Is our means height of the cylinder is 4 into 0.7 into 0.7 into 1.4. This much centimeter. It is like this one. You have to just multiply it, or you may multiply it 1 by 1. 4.2, no, 5.6. So multiply this 4 with this 1.4 first. 5.6 into this is like our 7 7 ja 49. Go for multiplying this. You can get it. Multiply this and get it. Right, multiply this. 9 6 ja 54. Then go for multiplying this with this one, then this with this one, and add it with this 5 as carry. Then lastly write the 4 multiplied by the 5, you will get it. Yeah, what is the result?
So 2.744.
3.
So 2.74.
It is 2.7.
Yeah. 4.
2.74 only, or 754?
So 744.
Yes. The unit you never forget, it is given as centimeter, so it is this one. So this was the height of the cylinder that we have calculated. Here is our 2.744. Now the question is calculating the surface area. Therefore, surface area of the cylinder can also be calculated. Substitute the formula for the surface area of the cylinder. Surface area of cylinder. So here the surface area means the TSA we need to calculate. And we are knowing that for that the curved surface area have to first write it. It is our 2 pi r multiplied by h, and base and top the 2, and they are the disk. So 2 pi r square. The same thing, the 2 pi r can be taken common. It is our r plus h. But keep in mind, it is related to cylinder, so do not forget to use the suffix c everywhere. C to avoid confusion that whether this is r for the sphere or the cylinder. Go for substituting. 2 into 22 by 7 into the r. The radius of the cylinder is our 6. Then it is our 6 plus 2.74. Even you can approximate this. So whatever the result that you will get, that will give you the final answer. Okay. So these questions are very simple. You have to just apply the concept of transformation where the volume remains same. From this volume, either you calculate the unknown radius or the height and use it for the surface area. Okay, let us go for the question number 2. Any doubt, student? Then please ask. Otherwise, these questions are very easy. Let me take the question number 2 now. So in the question number 2, also you have to draw the figure first. Metallic spheres of radii 6 centimeter, 8 centimeter and 10 centimeter. Student, it is not the radius but radii, means it is the plural. Means 3 spheres are given. So you draw the 3 sphere first. They are of the different shape. So you may write this as R1 is equals to 6 centimeter. Another as the R2 is equals to 8 centimeter. Another as the R3 as the 10 centimeter. It is like this one. These are the 3 spheres which are given. they are melted to form a single sphere. Means all these three are melted to give a single sphere. Means it will give a bigger sphere. Find the radius of this resulting sphere. Let us denote it by capital R. Okay. It may be asked for calculating the surface area of new sphere. The same concept. After calculating the radius, you have to calculate the surface area also. So let us go for calculating the radius of new sphere first. Then we will go for the surface area. So what will be the volume of this first sphere? It will be 4 by 3 pi r1 cube. Volume of second sphere 4 by 3 pi r2 cube. Volume of third sphere same 4 by 3 pi, but radius is now r3 their cube. And for this new sphere, the volume of this new V1 we may write is 4 by 3 pi. New radius I am denoting by capital R, so that R cube. Get it? So they are melted, means the volume remains the same. Means according to question you can write directly. What is there? These two are melted together, means the volume of these three will be equal to the volume of new one. If you want to write in more detail or language, you may write, or you may directly write this as V1 plus V2 plus V3 is going to give us the new volume Vn. Go for substituting. 4 by 3 pi r1 cube plus 4 by 3 pi r2 cube plus 4 by 3 pi r3 cube is equals to, for the older one, 4 by 3 pi capital R cube. Here we are getting 4 by 3 is common everywhere. Means from the first these three, 4 by 3 pi can be taken common. Then we can write R1 cube plus R2 cube plus R3 cube. This is equated to 4 by 3 pi capital R cube. Now this 4 by 3 pi can be cancelled on both sides. So this simply implies that we can leave the pi and 4 by 3, means R1 cube plus R2 cube plus R3 cube is going to give us new radius their cube. Now go for substituting. Given as 6, 8 and 10. So you may write R cube is equals to 6 cube. I am just rearranging, bringing left on right side, right on left side. Plus 8 cube plus 10 cube. Go for this one. So this implies R. For this you have to take the cube root. Do the same thing. So 6, 36. So 216. Then 8 cube. How much is the 8 cube?
512.
Yes, 512. Good. 10 cube. It is our 1000. Go for adding this. It is our cube root of. So be careful while you are adding or simplifying this, because there is a cube root. It is for all. So first you need to add these three, then you shall go for taking their cube root. Many a time students are committing mistake in this. So it becomes 728. Sorry, 1728. Can we take the cube? Or is this cube of anything?
Yes, sir. 12.
Yes?
12.
Very good. So it is the cube of 12. How to get that 12? Even the last you can take and the first two you can adjust and get it. That trick I will tell you later. Okay, so ultimately this is going to give you 12. Therefore, the radius or required radius is equals to 12 centimeter. It's so simple. It may be asked what is the surface area, then you shall take 4 pi capital R square. You may substitute it here. So it is like our 4 pi 12 square. You can get this value. It's very easy. So this was all about how the conversion is occurring. So here I had told you the two important things, the volume remains same. Even just one object converted into the other, or more than one object is melted and converted into the single. There is another application of this that is considered as the flow. Okay, so the water is flowing through a pipe, and later on this water is collected into another rectangular tank. Then what will be the level rise? That is also the application of this. So let me solve one question based on that concept, then we will come back. The same thing, student, this question number 3 and 4 are also very easy. So let me even explain the question number 3 also, though these are very easy. It is given that 20-meter deep well of diameter 7 centimeter is dug, and the earth from digging is evenly spread out to form platform 20 meter by 14 meter. Are you getting? Means a cylinder or a bell in the shape of cylinder is dug. So while digging this well, so this well will give you the earth that will come out of this. That earth is spread in the form of a rectangular platform of length. This is 22 meter by 14 meter. And radius of the well which is dug is our 7 meter. So this radius can be calculated by, means this is the cylinder, or W you may denote. It will be 7 by 2 meter. And it is given that the depth of this well is our, you may write D or H of the cylinder, it is our 20 meter. How is this situation? Are you getting? Means our earth's surface is like this one. Getting? No? This is our earth's surface. So from this earth's surface, this well is dug inside this earth's surface, and whatever the earth that is coming out, that is being spread in the form of a rectangle. So while placing this, the earth over this rectangular area, the height will rise. What is this height? This height is equals to how much? This one is asked. So student, what we have to do? The same thing, the volume of earth taken from the cylindrical well have to equate it with volume of the cuboid here. Getting? So only these two things we have to do to calculate the height of the cuboid. So you may write volume of this cylinder first. Volume of cylinder is obtained by the formula pi radius of cylinder square into depth, whether depth or height mean the same thing, of cylinder, and the volume of the cuboid or rectangular field, we may write the R here for the rectangular field over which the height h is going to raise, is obtained by L into B into H. Get it? You can substitute the value, or first you equate it, then you finally substitute it. Get it? Since the earth taken from the well is converted into the shape of cuboid, so the volume of cuboid will be equals to the volume of the cylindrical well. From which the earth is taken out. So it is the finally earth or the volume of the earth that we are equating. So volume of cylindrical well giving the earth. So volume of this cuboid is given by L into B into H, and the cylindrical well is pi RC square HC. So height of this earth placed in the rectangular form is obtained by just go on dividing it, pi RC square HC by L into B. Now after rearrangement, just substitute the numerical value or the data given to us. So this can be written as pi as 22/7 into HC cylindrical shape and RC. HC is 20 and RC is 7/2. So let us substitute 7/2 there is square into, rather than a square you may write 7/2 two times. That may be helpful in cancelling the data. Into HC is our 20, and this have to be divided by length and width. The length and width are 14 and 22. Student, I had already told you what this represent. Means this 14 and 22, they are even in denominator. So let me cancel this 7 and this 2 with this 11. So it is like 11 into this 2 with this 10 into 7 into 10, and in denominator it is our 14 into 22. We may cancel this 2 times, and this 7 also 2 times. Now this one of these two can be cancelled with this 5, so it remains 5/2 meter. This is the answer, or 2.5 meter. This is the, so the height of the rectangular field that will raise because of the collection of earth is 2.5 meter. Okay, so it is only this one. Here we have equated the earth. It is possible that the water taken from the well maybe can be placed into this other shape. then the volume of water need to be equated. Or maybe possible that the water is flowing into a cylindrical pipe, then the volume of the water inside the cylindrical pipe up to certain length or for certain time have to be equated with the volume of water collected into the tank. So let us go for that kind of question. That is the last type of question from this chapter, or the last concept. Yes, student, written? Or any doubt, then please ask. Student, this transformation concept is very important, and every year the question is asked. Irrespective of any gap, every year the question is asked, either in the form of this well or the flowing water or recasting. These are the only three concepts, and the one of the concepts are, or one of the concept is always asked. The question number 4, a well of diameter 3 meter is dug 4 meter deep. The earth taken out spread evenly all around it in the shape of circular ring 4 meter wide to form embankment. Find the height of the embankment. Can you calculate? It's also very easy, but many a time a student are getting confused. So let me do this question number 4. Though it is easy, but I'm giving you the hint. Students, the first thing you have to draw the figure correctly. Once you draw the figure, you can get the result very easily. So drawing the figure is very important. So for the question number 4, a well of diameter 4 meter, sorry, a well of diameter 3 meter is dug 14 meter deep. Are you getting? You may consider this is the ground. Okay, from this ground a well is dug. You may consider like this. The well is dug like this. So this ground will open from here. On opening, we will get like this. It is like this. Now, whatever the earth coming from this well, that is going to spread around this, even around this cylinder to form an embankment. So how it become? That we have to understand. So let me write first the depth of this cylinder. That will be the height of cylinder, even if you denote it by D or HC as 20 meter, not this one. Student, from the question number 4, diameter is 3 meter. So this radius of cylinder is 3/2 meter and dug 40 meter depth. HC is our 14 meter. It's okay. Now whatever the earth coming, that is again put around it, means the earth will taken out and it will be placed here. More earth will be taken out and placed here. More earth will be taken out and placed here. More earth will be taken out and placed here. This way a circular track or circular elevated track will form. That circular elevated track or band is called embankment. Get it? So this way, lastly you will get placing or spreading the earth taken from this, it will get this shape. Let me draw in different color. The earth will be taken, let us consider it is spread to certain width. The earth taken out has been spread evenly around it in the shape of circular ring of width 4 meter. So it is given that the width is 4 meter. This is your 4 meter to form an embankment. A student, keep in mind, it is around it means this 4 meter is from the end of this well. Get it? So from this you have to take the 4 meter here and 4 meter here. Means ultimately it will form another cylinder or this circular path. Sorry, let me take the other color. Get it? This way. But it also has some height. It is just a plane that we have allocated over the ground, but it sorry student, it was a network issues. So student, the earth taken from the well is spread all around it so that an embankment is formed. And let us consider the height of this embankment be HE. It is asked find the height of the embankment. This is required to be calculated. Okay. So in this case, whatever the volume of earth taken from this cylinder or the well, what is that well? The well is only this much. Keep in mind. The volume of earth taken from this well have to be equated with where the earth is collected. The earth is collected in the shape of cylindrical cell, not a complete cylinder. What is that cylindrical cell? The cylindrical cell is this one. Are you getting? It is in between these two. One is the inner radius. Inner radius will be exactly matching with the radius of the well. And outer radius can be determined by adding the width of this embankment, which is 4 meter given in our question. Okay, student? So the volume of the earth lies between these things. Okay? The earth is lying in this region only. The earth is in this region only. So we need to calculate the volume of earth from the cylinder, which is in the bottom, equals to volume of the earth in this cylindrical cell or cylindrical embankment. That is the only thing that we have to do. So how to calculate? So volume, here we can write volume of earth from this cylinder. What will be that? It is given by pi RC square into HC. It's so simple. But what is the volume of earth in this embankment? A student, we have learned earlier that this volume can be obtained by first calculating the volume of outer cylinder minus the volume of the inner cylinder. Okay, so right, volume of the cylindrical cell or embankment is equals to volume of outer minus volume of inner. But this embankment is having the width 4 meter. So this 4 meter can give us the radius of this outer this much cylinder. So R out as the inner radius, which is same as the radius of the cylinder, RC. So R out is obtained by RC plus 4 meter. And inner, this is the RI or inner radius, RI, same as RC. So, and the height of this embankment we have assumed as RHE. So go for substituting here. Volume of outer means the bigger cylinder is obtained by pi r square. But in this case, we need to take outer radius or the bigger radius. So we make it keep r out square and height is HE. And for the inner one, pi Ri, though this Ri will be same as the radius of the cylindrical well into H embankment, it is uniformly distributed. It is given pi and He can be taken out. What is left is R out minus Ri is same as Rc there as well. So what we have to do, we have to just equate these to volume. That's all. It's so simple kind of thing, but the students are not able to draw this figure. That's why they are committing mistake. This question was asked so many times, not once, twice, but I can remember it was asked nearly 3 to 4 times, means even 4 to 5 times in your board in different year. Means after every 3 or 4 years, the same question, even just by changing some of the data or even with the same data, it is asked repeatedly. So right, according to question, volume of embankment of the embankment means this one. So many disruption, students. Yes, sister, are you getting?
Yes, sir.
Okay. Students, we were discussing for this question number 4. The total volume of the earth taken from the cylindrical well, which is marked here in yellow, should be equals to the volume of the earth in this embankment. And volume of the earth in embankment is calculated by calculating the volume of the outer cylinder minus the volume of the inner cylinder. The volume of the outer cylinder, for that the radius is obtained by taking the inner cylinder radius, added it with the width of this embankment at 4. This we will do. So it will be our 3 by 2 plus 4. So you may add it. 4 2s are 8, 3, 11 by 2 meter. So R out is our 11 meter, and inner radii or inner radius for this embankment same as the radius of this well over which this embankment is done. Otherwise the earth cannot be hanged in open space. Okay, so that will be the radius, and it is given in question. It is uniformly distributed around this well itself. So these two volume have to be equated. Volume of cylinder is pi RC square H, and volume of embankment pi HE R out square minus RI square. Equating this, the pi can be cancelled. On one side there is HC and on other side there is HE. We need this HE, height of embankment, is equals to RC cylinder square, height of the well or the cylinder, that divided by R out square minus RI square. This is for the embankment. Go for substituting this. So RC is 3 by 2. It is given that the diameter of this well is 3 meter. Therefore, radius obtained is 3 by 2. So it is our 3 by 2 square. Better to write in 3 by 2 into 3 by 2. The height of this means the depth of this cylindrical well, it is our 14. So write this as 14. Divided by R out. R out we have calculated the outer radius of this embankment 11 by 2. Because the 4 meter is the width of embankment. So this 4 meter is added here with the RC. So it was our 3 by 2 plus 4 to the 8, 3, 11 by 2. So it is our 11 by 2 square minus the inner one is our same 3 by 2. So 3 by 2 square. You have to just simplify this. That's all. Even a student are committing mistake in this simplification. So let me simplify. You may cancel this one of this 2 with this 7. So in numerator you will be left with 3 into 3 into 7. Initially you keep this is a smaller factor that will help in cancellation. So do not go for multiplying the numerator itself. In denominator we have the 2, 1 2 is left. Now another, rather than going for the simplification of 11 by 2 there square and minus 3 by 2 there square, you can use the formula. It is in the form of a square minus b square. So it can be used as a plus b into a minus b. That will give the simple result. So it can be written as our 11 by 2 plus of 3 by 2. Okay. And another time it will be 11 by 2 minus of 3 by 2. So this denominator I am doing the rough calculation. Then I will just substitute it here. So 2 is there. 11 plus 3 is our 14 by 2 into 11 minus 3 is our 8 by 2. Here we are getting that even this get cancelled to 7 and this get cancelled to 4. So here we can write 7 into 4 itself directly. Okay, rather than going for bigger calculation, these are the things that we need to keep in mind. So this calculation is important for this chapter, because if your calculation is not correct, though your formula is correct, marks are deducted. So please solve it properly. Here we are getting that this 7 is being cancelled from the 7 of this numerator. And is there anything else? Nothing. So it is our 9 by 4 to the 8 meter. This is our. Therefore, height of embankment is 9 by 8 meter. Okay. If you want, you can divide it 1.125 or 25. So this was all about this. So questions are very easy, but the students are scared of such questions because they are not practicing or they are not understanding. In many books, you will get this calculation at different places, then adding, subtracting. Please do not do like that. I always try to make the things more simpler. Always do the calculation at the end. First, what is the concept? You apply that one only. So the concept is only that the earth taken from the one form is equals to the earth in other form. So that we have equated, and that while equating this volume, the unknown quantity like height of embankment can be calculated. It's so simple kind of thing. So do not get confused by watching the solution from any guidebook or at the net. Now let me go for the other kind of question. A student, even the question number 5 and 6 are very easy. Are you getting what is there? So container shaped like right circular cylinder having diameter 12 meter and height 5 meter is full of ice. The ice cream is filled into the cone. Are you getting? So the cone is there. I'm just giving you the hint. I will not solve the entire one. So it is given that a cylinder is there. For the cylinder, there will be the radius of the cylinder. It is given that the right circular cylinder having the diameter, so radius is 12 by 2 means 6 centimeter, and the height is there. Height is given as 15 centimeter. Full of ice cream means this box contains the ice cream. Now this ice cream is placed in cone. So the cone is now there. So the cone have their new radius. You may call this as R. See, our cylinder and cone both are starting with the same. So let me write this with the R2. Of height, this height of this cone is given, means H2 is given 12 centimeter, and diameter is our 6 for this cone. So the radius is 6 by 2 is equals to 3 centimeter. Okay, student. Find the number of such cone. Here you are getting that entire volume of the cylinder is not just converted into the single cone, but likewise there will be so many cones, because it is given that the volume of this entire ice cream have to be converted into the concept. So on, let us consider such cone are n in number. That even can be calculated very easily, but let me take the general form. Let n cones are there. So n cone can collectively make the ice cream inside this cylinder empty. Means whatever the volume of each cone is how much? Means for the one cone, it is calculated by 1/3 of pi radius of this cone R2 square into height of this cone H2. Each of these have the same volume for this one. Okay, same V2, but this is the nth one. So what is the total volume of this cone? So total volume of cones, the same volume is occurring n time, so it becomes n times of 1/3 of the pi R2 square into H2. Okay, it is this one. Now what is the volume of this cylinder? So volume of the cylinder is pi. Yes.
So there is a hemispherical on top, hemisphere on top.
Not exactly getting what you want to say.
So there is hemisphere on top of the cone.
The n, such n cone we are considering. That's why we have multiplied it with n. And the formula for the volume of one of the cone is considered. All the cone are identical. It is given here in the question, no? Into cone of height 12 centimeter and diameter 6 centimeter. Yeah, one more thing is there. A student, one more is there. Hemispherical shape. So add that one also. I have missed that. So please be careful. Good. So that one also have to be added. In this, we need to add this. Every one cone have this hemisphere also. So this part also you need to add. For this, the radius remains the same. So for this hemisphere, the formula for hemisphere is 2 by 3 pi r. Here R2 is there, that much Q. So that also need to be added here. So this total volume, in this I need to add this 2 by 3 pi R2 Q. Just extend it. Add 2 by 3 pi r2 cube. This much. It is not ending here, but it is coming to this much. Now I think it is okay. Yes, hemispherical shape on the top, so that we have considered. Find the number of such cone. So calculate the volume of the cylinder. Volume of the cylinder, pi r square into h. Now this volume of cylinder had to be equated with total volume of the cone. It's so simple, and I hope you people can do it. I'm not going to calculate. Okay. Since n times of the volume is 1/3 of pi r2 square into h2 plus 2/3 of pi r2 square should be equated to pi r square h. Is it okay? Why? This extra hemisphere we have considered, this is the cone part we have considered to calculate the ice cream in one of the cone. It is that. So that's why this one. Now be careful in calculation. Keep in mind the radius of the hemisphere will be same as the radius of the circular area of the cone. That's why R2 is taken common for both. Are you getting? R2 is common for both. You may take this n outside, pi outside, even 1/3 also outside you can take. And R2 square also outside you can take. 3 is also outside you can take. What is left from the first? 1/3 pi r2 square is outside, so h2 we need to calculate the number itself, so n already outside on one of the side, plus 2 is there, pi and 1/3 is out, it is only this much, is equals to pi r square h. Pi can be cancelled. Are you getting? So this implies n will be r square h. This r is for the cylinder, student. So this figure is very important. In examination, you also have to just draw the figure, write this condition and calculate it. No need to write bigger language and other thing. Again and again I am reminding. And just making this equation, that's all. Always try to make the statement into the mathematical form by writing the equation. That way the chance of error is always reduced. Otherwise, many a time students are separately calculating one volume, dividing whole volume like that. Many times they are missing what to do. By that way, the questions are solved in many of the guidebook. So avoid that technique. I always applying the basic concept is what? The total volume in different form or in these cones is equals to total volume. Since the cones are n in number and all of them are identical, so I have calculated the volume of one of the cone which is having the hemisphere at their end. So for calculating the volume of one of the cone with hemisphere, I have added the 2 volume, multiplied it with n, then n is calculated just by cancelling the common factor and rearranging it. So the 3 in denominator on left will move to the numerator, and r2 square divided by h2 plus 2 in denominator. Okay, this is your answer. And I hope you people can substitute it here. Or shall I substitute? I hope you shall do at least this much. R is our 6 square. The height is also given 15. It was for the cylinders, so for that we have substituted. And R2 here we are getting for the cone, it is given as the 3, that even we had calculated, square into, for this the h2 height of the 2, it is given as 12, so that 12 plus 2. Now hope I you people can do it. Okay, so even this can be converted into 4 directly. So 3 into 4 into 15 divided by denominator become 14. So you can convert it into this 7, and whatever you will get that much. It will be just a number. A student, if it is coming in the decimal form, so the complete number you shall take. Yes, it is coming in the decimal form. 3 and 7 is there. So the complete number you have to take. How much ice cream can be filled? It is asking for that. So the complete number only, or integral part you have to take. So take the integral part, or let me even divide it and write the final answer. So 345 by 7. So 7, 6 point something. So point is not possible. Always n is integer. So you have to take this 6 only. Even 6 point, sorry, 6.42, something like that. Therefore, number of cone that can be filled is 6. What is the integral part? That you have to just take. That's all. So this is one kind of thing. So you should be careful. How many silver coin of 1.5 centimeter in diameter and thickness? This one means this cylinder it is formed. So you have to consider for the question number 6, let there be n such cylinder and its volume have to be equated to get this dimension. LBH means n into pi r square into h of the cylinder should be equals to length into breadth into height. It is given that cuboid is there. Okay, so this is the hint for this one. That's all. Okay, so this was the question number 6. Now let us go for, you have to do all this question in your home also. Do not think I have to solve it here and it's over. You have to do it. Now let us come to the last 2 questions. I think we will finish this question. By this, the entire exercise will be finished. So question number 8. Here, it is also based on the transformation, but it is the flow of water. Water in a canal 6 meter wide, 1.5 meter deep is flowing at the speed of this. Are you getting? Means it is given that a canal is there. Canal always in the form of rectangle we are considering, means rectangular cross section, or in the form of cuboid, means it has some depth. Let me put the depth like this. Let me put the depth like this. So it is indication of their depth. Are you getting? The water will come through this and it will fall here. So for this 6 meter wide, it is given that this width is 6 meter, or you may draw in this base form also. This base is your 6 meter, or let me draw with a different color. It is our 6 meter. This is the width. And depth means from the ground. What is this depth? It is this one. So you may write this width as B and depth as H. Height or depth mean the same thing as 1.5 meter deeper at a speed. Now it is given that the water inside this is flowing at a speed of your 10 kph. Okay, so be careful. Here the speed is given in kilometer and the length and the width and depth are in meters. So better to convert it into meter per second or meter per minute, like that one. How much area will it irrigate in 30 minutes? Now it is given that this water is going to spread over an area. If standing water, if 8 centimeter standing water is needed, means you might be getting in a pond or rectangular tank, the base is in the form of rectangle and the water get accumulated in the form of height. So the shape of the water present is the cuboidal shape. So here standing water means the height of the water that will be accumulated here. So you may consider the water get accumulated to certain height rather than drawing the entire cuboid. You may just draw like this. Height of water is our 8 centimeter. And the area, how much area will it irrigate? So base area is required. And we have learned that if we multiply the base area with the height, we are able to get the volume. That concept we have to use. The volume of total water used in irrigation is area of the field multiplied by the standing height. So it is this one, volume of water in field. It is this one. Are we getting? It is only this much. Now, from where this water is coming? Water is coming from this canal. So what is the volume of water which is coming out of this canal in 30 minutes? I need that one. So I need to calculate the volume of water. It is very important question, student. Every year or alternate year this question is asked. So volume of water coming means all the water which is accumulated in the field is coming from the canal. From the canal, the time is given here in 30 minutes. The canal in 30 minutes. These two volumes have to be equated. But the question is how to calculate the volume of water which is coming out. A student, very simple. This canal is in the form of a cuboid. You just calculate the volume of cuboid. For calculating the volume of cuboid, we need certain length, its width, and its depth. Only these three things are required. Already their width and depth are not. So it is just a question of calculating the length. How to calculate the length? For calculating the length, so the length of water which was present or which is able to travel in 30 minutes up to the end is able to fall into this rectangular field. So that length can be calculated by velocity of water into the time taken by the water. Which time? The water at a distance of 30 minutes backside or behind this field in the canal, they are also able to reach to this field. That only we have to consider. So only that much will be the length of the canal. Means the water present in the length of VT is able to travel through this canal and they are able to fall into this field. It's that much simple. So how to calculate? So this is calculated by length of water into breadth of the canal into height or even the depth of the canal. Let me put the canal C here. It is the field F. Let me put the F, HF, and here HC and HC. It is this. It's that. Now this length can be calculated by calculating the, since you are knowing that distance is equals to how much? Speed into time. That formula, because wherever speed is given, multiplied by time, you can get the total length. And here we are observing that the water is traveling, means the water which is able to travel up to this field in 30 minutes, all those water in the canal is able to fall into the field. It's that much simple concept. So that's why this length we are considering. So it is velocity of the water into time taken by the water into breadth of the canal into the height of the canal or depth of the canal. This. Now, what is this velocity, student? Important thing is here that while I am applying this V and T, what is the unit given for this B and H? In the same unit, the length or the speed should be considered, and whatever the unit of the T given, the same should be present in the speed as per unit. Means if the here the time is our 30 minutes, so we shall keep in mind, rather than this kilometer per hour, this need to be converted into minute. Okay, how? From this 30 we need to multiply so that this minute will get cancelled. One thing. Now, once this speed is given in kilometer, but the width and depth is given in meter, so we need to convert this kilometer into meter. So your duty is first to convert this V as, I'm converting here, since V is equals to 10 kilometer per hour, this need to be converted into meter per minute, so that multiplying it by 30 minutes, the time minute will cancel. Okay, and multiplying this meter with the breadth and depth, the meter cube will be obtained, and the meter cube shall also be on the right hand side. Though it is given in the centimeter, you may convert it into the meter or even centimeter, but in later stage. So this need to be converted into 8 by 100 meter, that way, or 0.08 meter. So that unit conversion in such a question are very important. So convert it. 10 kilometer into meter means I need to multiply this with the 1000 so that it will get converted into the meter. And per hour have to be converted into the minute. So 1 hour shall be replaced by 60 minutes. That's all. Only this, one of the 10 will get cancelled. Or even if you wish, you can cancel this as 500, it becomes 1000. So 500 by, only the 2 is being cancelled, by 3. It is our meter per minute. Okay, student? So keep in mind, this we are going to use here. You can say, so along with the unit you first write, then you can observe it. So for calculating this, Though in a standard form, I will just equate this much with A into H this much, but just for calculation sake, I am writing here. So I shall use 500 divided by 3 into the time. Here it is in per minute. So if you have doubt, then you may write this as meter in numerator and 3 minute in denominator. Width, the width is given as 6 meter and the height is given as 1.5 meter. Okay, student. So this much. So this much calculation. So it was this one, but with this we need to multiply with the time, or even we can put the time itself here in between. Even we can put the time here. The time is our 30 minute. Here we are observing this minute and minute is getting cancelled. And meter become meter cube. Means it will be the meter cube. It will be the volume. So this way you have to anticipate. And this is the easiest method. Many a time students are thinking dividing time, multiplying time, they are getting confused. No. We are just calculating the volume of water in canal. Only the question is calculating the length of the water present in the canal. For that we are using V into T. But care have to be taken. V, the distance for this V should be in the same unit in which this width and height are given. And the time means per hour or per minute, this should be taken. It depends on the time T given. Here it is given in minute. Therefore, we have converted kilometer per hour into meter per minute. Only this small calculation you have to do, you will get the correct answer very quickly. So this I have just substituted here to show you. Now, what is required? So here during irrigation of this field, the volume of water present in canal will be equal to volume of water in the field. So you can write volume of water accumulated in field, accumulated or collected in field will be equals to volume of water present in canal. And how much volume we need to take? The time for which it is considered. Getting no? Only that much volume of water from the canal. That's why we have taken the 30. That gives the length. So just substitute area of field multiplied by height of water in the field will be equals to length of the canal, breadth of the canal, LC, BC and HC. It is this one. You can substitute. Or H field, sorry, H is already given, the area is required. Let me carry one more step. Of the field into height of the water in the field. This LC is obtained by speed of water or velocity of water into the time for flow of water into BC into HC. So area of field is equals to V of the water into T for flow of water. You may add the WW here. And BC into HC divided by H of the field. Now be careful regarding the units. That's why I have substituted velocity of water or speed of water rather than kilometer per hour. We have converted into meter per minute because the time given is in the meter per minute. So substitute it. 500 divided by 3. This is in the, if you have doubt, you may put this unit also here, and then finally cancel the unit. Into 30 minute, the width of this canal, it is given as our 6 meter. So 6 meter into the depth 1.5 meter. A student, everything given in the numerator is in the term of meter. So HF need to be in meter also rather than centimeter. Here it is given that 8 centimeter of standing water. Are we getting? So we shall not take the 8 centimeter of standing water. Rather we shall choose 0.08 or 8 by 100. Means 0.8 meter. Putting the unit, you will get, the unit will get cancelled. The minute will get cancelled. One of the meter with the meter will get cancelled. You are getting in numerator, it will be the meter square, means that will give the area. So dimensionally or unit wise it is correct. So just go for cancelling this, you can get this. Decimal, remove this. Decimal, 3 tens you may write. So it becomes simply our 5, 1, 2 was already there, one more 0 is there. Then 5 into 15, 90 is there, divided by 8 is there. You can get this. So how many? This much. Put it. Sorry, student, one more 0 was there. Not 0.08. You shall take care. 0.08 it was. 0.08. Okay. So one more 0 we shall substitute in the numerator. So 9 5s are 45. 1 2 3. 2 more 5 is there. Then divided by 8. This much meter is.
So one more 0.
One more 0 is there? Yeah, exactly. Get it? So you will just, it is divisible by 8, you will get the exact number. Okay. So it is so simple. So student, be careful. Do not use the technique of like many a time some time is given and something, some division and many ways of solving this question. They are, means in most of the book they are using that technique, but the students are committing mistake in that technique because they forget where to multiply. So my idea is that, or what I want to tell you, you calculate the volume, just equate it. For calculating the volume, you have to take the help of this speed and this time, because this is speed into time, means the speed of water into time taken by water, that will give you the length of this canal. Means you are getting that how much water, so water at this length of VT at this end, let me consider this was at the t is equals to 30 minutes. So all the water which were present at this end at the 30 minutes, they are able to travel over this canal and they are also able to fall. We have to consider up to 30 minutes. Those water which are beyond this 30 minutes, they are not able to fall in this field. Okay, they will take more than 30 minutes. So that's why we have considered only the length of the canal with the help of V and T. The width is already given and depth is already given. So this LBT means the length of canal, width of canal, height of the canal. This length is calculated by speed of water into the time for the travel of water. Only thing is that you should be cautious about the unit so that the unit get cancelled. If it is in the time is given in minute, you shall convert kilometer per hour into the minute. Okay, then substitute the minute so that minute will get cancelled. So only that much, that's enough. So this was all about. So let us stop the class here. This way I had explained each and every concept related to the transformation or conversion of shapes and its application by solving good number of questions. Question number 9 is exactly same as question number 8, where it is given that a pipe. So in this pipe, what will be there? The volume of cylinder of water you have to consider. So in this case, this LC you will calculate by the same way, but this volume you need to calculate by LC into the base area. Area as pi r square you can calculate. Of the internal diameter is given, canal into the cylindrical tank, another one is also cylinder, means it is like this one. You can get like this. It is this one into the another cylindrical tank, this one. So this length again you will calculate by the same technique what I had taught to you right now. 10 meter diameter, other thing is okay. The water is flowing into the pipe at the 3 kph. So this 3 kph, how much time it will take? Now you have to equate and calculate this time. Getting? So you will maintain this time. But here the things are given in meter. So you need to convert this into 3000 meter per hour. You can maintain the time into hour. This way, the time in hour you can calculate. So please try this question number 9. If you could not get it, then I will solve it tomorrow. So calculate the volume of this cylinder by calculating the L of this cylinder into pi r square, the base area, means this area. This LC is calculated by V of water into T of water into pi RC, this much square. It is for this pipe. I am considering for this pipe. Similarly, the same thing you also have to apply for this one, but here pi r of field square into the height h is also given, h of f. Just equate this. Only this t you have to calculate. This w means the speed of water. You shall keep 3000 meter per hour. Means the hour, the t in hour you have to take. So here you will get this t in hour itself. You want to convert it into minute, later on multiply it by 60. Do not multiply initially. Then pi r is already given. You will just substitute and you will just equate these two. Okay, I hope people will get it. So this was all about the today class. Let us stop the class, otherwise it will go too long. So a student, now your homework, this question we have already done. The will of diameter 40 meter depth. This question we had already finished, though it is also copied here. So write down the homework. From my side, even I have also finished this chapter, but tomorrow is the time for you people to ask the question. Whatever the new concepts I have searched and I have explained everything. Even last day I had given you all the concepts, but you have to do a bit more practice on those exercises, though they are also belonging to class 9. So our textbook exercise 13.1 given yesterday, 13.2, 13.3, all these three you do. You have to finish this, okay? And tomorrow afterward you have to ask your doubt. Though I had solved the 13.3, almost all the questions I have solved, but you also try once. You have to solve by yours and ask the question from this 13.1 and 13.2 also. So next class tomorrow again at the same time, so around 8. A student, some of you are coming late, though myself get delayed or late many a time because of class 9th. Okay, student, any doubt then please ask. Whatever we have discussed today in that, no doubt, then we shall end the class, and tomorrow there will be the doubt class. of this chapter and even the previous chapter also. So this chapter number 12 and 13, your doubts, okay now? So please ask, please collect your doubt and post your doubt in the WhatsApp so that we can discuss it. From my end, I have explained each and every concept, but still if you people are not able to do the calculations, all those things I will explain tomorrow. Okay, student, any doubt? No doubt? Then